Good morning. Let's get started today. So, today the three lectures we are going to focus some of the current challenges I think or issues I think in food processing that probably being addressed which are common to various food processing methods and probably this will continue to go for the next several years. So, the first topic we are going to address is the energy water use in food processing. And today there is a lot of interest in looking at the sustainability and simply put the sustainability basically may be defined as a development that meets the needs of the present without compromising the ability of future generation to meet their own needs. So, I think I think you are able to do what you want to do today, but without compromising the needs of the future. Sustainability broadly speaking has three components: the environment, the social aspect, the economic aspect. So, you cannot just have sustainability primarily focus on the environment and social without without paying attention to the social. So, you have to have the economic, the social and the environment all needs to be balanced, so that you have a sustainable society. From a food company point of view, you probably have all these three things interact. You have a broadly speaking an environment, a social and an economic subsystem. And let us say that you have the company here, the company probably going to receive some energy, water, minerals, all those things. It occupies certain land and it uses some capital and it also have certain water here. So, it also use some labor. So, with all these things it is going to produce food and the food is going to support the population growth, feed the people convenient food. That profit probably generates some taxes, which in turn helps the society or the government to pay for social projects and things like that. With the population increase, because people are healthy and they are eating well, it increase the land and water demand, because there is going to be more and more demand for that. But one of the outcome of that is also with the air emissions, wastewater, solid waste and so on. So, today the food processing is basically a linear. So, that means what I mean by linear, what I have is you start with the raw material and then you probably process it, then send it to the retailer or distributors, then consumer, then you probably generate waste. So, the waste is going to affect the environment, but there is no effect to fix this problem. So, what we need is a circular economy or circular concept. So, that means maybe you start here raw, then you go through and then you kind of have a circular concept, so that it is kind of minimize the waste and a better utilization of the resources. So, here just to illustrate the same concept, here you have the raw material, water, and then you probably have ingredients and other things which are supplying food processing plant. Processing plant produces air pollutants and then you produce products, but it also generate wastewater, but you also create some pollutants along the way when you distribute, and then when it goes to the consumption, along the way you create some pollutants. And then it all kind of done in a linear manner without any effort going to recover and have a circular economy. So, there is a lot of waste being generated part of this economy, and I think that is where there is emphasis on sustainability and also emphasis on improving the circularity. The circularity concept is very simple, very interesting, but doing it in practice is going to be much more challenging. So, how energy intensive is food processing? like I think whether you do the pasteurization or you do the canning or you do the evaporation, spray drying or any other food processing methods, it is very highly energy intensive. In fact, I think some of this data I am going to provide is probably for the US based, but in India probably you may have a similar statistics. If you look at the energy consumptions consumed by different category of industries, chemical manufacturing is probably highly energy intensive, followed by petroleum, pulp and paper, and then the food manufacturing. You are among the top 5 in the list. So, there are kind of lot of energy is being used. When you are using lot of energy, you are probably going to generate also lot of pollutions, CO2 emissions and so on. One of the things is compared to some of the larger petroleum, pulp and other things, food processing is so diffused because there are so many of smaller segments, larger corporations, medium corporations, small corporations. So, you may not realize that food processing is so energy intensive. To give an example how much energy they are spending, here so many trillions of British thermal units. Look at the food processing, it is spending about 1511 trillion British thermal units. So, this is quite high, and what it is it is coming from fuel. Most of the food process operations, they use fuel. So, fuel for what? Fuel for heating your furnace, your like equipment, so that you produce steam, and then the steam is used for heating various food process equipment and so on. They do not use much electricity. If at all they use electricity, that is for running some pumps, lighting and things of that nature. So, a lot of the food processing plants have some separate facility where they produce steam on site, and then that is kind of what they use for various operations. So, that requires a lot of fuel, and when you produce steam, it produces like with the fuel you probably produce a lot of emissions, plus in addition to that, when the steam is kind of transferred from one location to another location, you are going to waste a lot of steam. So, that means it is also add to some of the environmental effect. Whereas, if you use electricity, you can be much more efficient in converting that electrical energy into useful preservation action. So, that we will probably talk later. So, when we use food process operations, we use this for various things: heating, pasteurization, cooking, blanching. A lot of the food process operations are there. In addition to that, you can add to the list on drying, evaporation, so many things. We do refrigeration and freezing. Again, this is country to country different. In the US, they have a very robust refrigeration and freezing network. So, they can able to maintain that, whereas in India, probably some of the network is relatively in infancy. So, it is kind of evolving, but nevertheless, you use some energy there. You can do processes like extrusion, and then you do energy for pumping, slicing, mixing, different things, as well as use of lighting for the facilities control systems. If you look at the big picture, how much energy food processing use, about 52% of the energy is coming from natural gas or like fuel type of environment. Only 21% is electricity is used. So, what is the benefit when you have more natural gas, no petrochemicals used? It can lead to a lot of environmental effect. But imagine we swap these numbers. You probably have maybe 50% electricity used and maybe only 20% natural gas used. Then that electricity, there are many ways you can generate, right? You do not need to lay upon natural resources. You can probably use in India, for example, solar energy probably can be used. You can use a geothermal, you can probably use a nuclear. So, there are so many energy options available, and that also much more energy efficient because, for example, when you use high pressure processing, use the electricity to pump the to generate the pressure, and then the pressure energy is delivered to the product. There is not much wastage of energy along the way. Whereas if you use the autoclave for sterilization, you kind of produce the steam, then it is transmitted where there's a lot of transmission losses occur, and then from the plant side to your processing plant, again a lot of energy losses occur and so on. So that's where you probably something needs to pay attention to switching to more electricity based food process operations rather than relying upon some of the petrochemical type of operations. So within this you probably use about 59% process heat, 16% refrigeration, and then rest of them other categories of energy. What is process heat? So I mentioned when you do use steam to use fossil fuel to generate steam. From the steam you use that to heating your canning equipment or your drying various things, right. So that energy required to generate your vessel like the steam, that's oftentimes in the literature they call process heat, particularly in the chemical engineering literature. So that's probably almost 60%. So that's kind of very major factor which may contribute to the environmental issues with the food processing. And within the electricity use, you probably use mostly for simpler operations like driving your motors, lighting, refrigeration, and things of that nature. If you look at the energy distribution, you probably use about 70% of energy for heating and cooling, 12% for process equipment, 8% for facilities. So this is where you have opportunity to improve your energy efficiency. Right now this section use a lot of the process heating. So if you can able to switch to the electricity, you can probably improve upon your overall energy efficiency, and then also you can also help to reduce the impact, because you probably don't have one food processing plant, you may have thousands of food processing plants, each one contributes a little bit, you can get a major thing accomplished. And this graph just to highlight the same thing a little more graphically. So you can see that conventional boilers which uses process heating, you can probably have a major chunk of the thing, and then you have process cooling, electrochemical machine drive, all those things. So according to some estimates, this is from the US Department of Energy, about 1.2 quad of energy generated, like probably 45 million metric tons of energy that result in some emissions. So here we are going to look at how, if you make certain products, how energy is kind of used in different cases. So for example, you are making milk powder, and if you make the milk powder, this is the how much energy needed per kilogram of product. So many megajoules per kilogram, and you can see that you probably need about 15 megajoules per kg product which uses the fuel, whereas only about 1 or 2% use electricity. So that's kind of the major portion. Whereas if you probably look at something like a cream, you probably use very minimal energy from the fuel, whereas about 1 you are using electricity. Look at ice cream, 2.89 electricity, and then 1.63 you use the fuel. So you can see that depending on the different processing products, you probably have how much electricity you use, how much fuel you use. The goal is to maybe increase the how much electricity you can use, then you can always generate the electricity through variety of different ways which have minimal impact on the environment rather than relying on the petrochemical type products. Here some additional things. Look at French fries, about 14 megajoules per kilogram versus 1.48 or 1.5 for the electricity. Whereas if you look at the jams and mild-made, it's relatively simpler operation, about 1.5 versus 0.49. So the take-home message is most of the current food products are energy intensive and they rely upon more petrochemical energy than electricity. So there is that's kind of lead to some of the potential environmental effects. And we talked about various food process operations in this class, particularly looking at the advanced thermal and non-thermal processing methods such as pasteurization, sterilization. But beyond that, there are many other so-called unit operations. So, for example, drying, you have evaporation, you have extrusion, you have spray drying. So there are so many unit operations there. Among all these different unit operations, one of the most intensive, energy intensive operation is drying. So, for example, if you are doing a drum drying operation, you are probably going to look at as the product is being washed, peeled, pre-cooked, mashed. So, let us say this is a potato type product and doing a drum drying, you are going to need about 6,350 PTU per LB of the product, whereas rest of them are relatively milder. So, drying is one of the energy intensive operation. So, there is urgent need for developing more energy efficient technologies to meet the or to significantly reduce the energy efficiency or increase the energy efficiency. Now, the energy efficiency can be improved couple of different ways. One, you can always recommend, okay, go and develop new technologies, and I think there is a room for that, but you also have opportunity to fine tune, optimize and improve the existing food process operations. So, we talked about drying is one of the more energy intensive operations. So, let us say you dry vegetables, and rather than directly dry the vegetables, maybe you can add a dewatering step where you take the vegetables and maybe find a way to remove the water, so that the dryer does not need to work that much harder to do your work. So, sugar beet battery where they may be drying, you can use this press to remove the water, so that you can able to put them into rotary dryer, so that you can able to save some energy there. Same way, a lot of the vegetables you can pressure treat them. So, for example, 300 megapascal or 400 megapascal pressure for a couple of minutes. What it does is, it is not done for the purpose of microbial inactivation, but it is going to permeabilize the cell membrane. So, that means like within a bacterial cell, like or your vegetable tissue, it is going to push the water out, so that when you do the drying operation, the drying kinetics can be much more faster. So, for example, if I have time versus the moisture removal, the one treated with high pressure may be much faster, whereas the drying may be smaller. So, this is HPP plus drying, whereas this is just a drying alone. So, you can able to accomplish much better drying efficiency. So, there are same thing probably we can say about PEF and UV. So, a number of the new technologies have that capability to permeabilize the water. So, lot of the processing plants use boiler. So, most of the time these are legacy plants, in that sense they are being operated 30 years, 50 years, so many years, and that means the maintenance, pay attention to them probably is becoming less and less. Lot of the boilers may have lot of salt deposits, and they may be poorly conducting heat, transferring the energy. So, there is a need can be by do that regular maintenance, you can improve the boiler efficiency. You can add some insulation so that you can able to have better efficiency. When you produce steam with the boiler, there's a lot of steam leak along the way. You probably, if you go to food processing plant, especially those using boilers, you can see some of them are really warm. Part of the reason is there's a lot of steam leak, and if you fix some of the steam leak, that can add up in terms of improving the energy efficiency. You can use energy efficiency motors, compressor, pumps, and another thing quite easily done is you can use the waste heat from one part of the process to another. Anybody know what is the classical technology that does that already? So in other words, you are heating a product, then you capture the energy content of the heated product to recover that heat from that to heat or cool something else. A classical technology does that already. Anybody know? It's the pasteurization. Like if you do the pasteurization study, you can see that when you have a raw milk coming in and then it's pumped through, initially it may be about 5 degrees or 10 degrees Celsius, then it goes through the homogenization, and then here you can see that it begins to heated by the outgoing processed milk. The processed milk already at a higher temperature, 72 Celsius. So that outgoing milk is going to heat the incoming raw milk. So two things happens. The temperature of the incoming raw milk going to increase, so you are accomplishing some heating, whereas the temperature of the outgoing heated milk going to decrease, so it's going to cool down. Then after that it goes to the homogenizer, remember the holding tube, and then you can see here this section you are using some heat to heat this to final pasteurization temperature, and then when you come back here you are giving out that heat to the outgoing or like incoming raw milk. Then after here you are using some glycol water to cool further, and then you can package them. So this section where you are recovering the energy from the incoming product to heat, in this case raw milk, is called a regeneration section. If you probably don't configure this way, you probably lose that heat energy as a waste, and you probably spend more energy to cool the product down. Whereas here we can kind of utilize that heat to capture and at the same time get a benefit. So many food process operations can be modified so that they can able to capture some of the energy efficient way of operations. We already talked about steam leakage. So 5 to 10% steam energy in steam lines, so you can probably capture steam there. And then we saw like boilers, same with the heat exchangers, lime deposits may be there, so that can be there. Now in the US, EPA has what they call energy audit, energy store plans. So they provide, they audit different equipment, and then they provide some certification. This is energy efficient machine. So food processor want to buy them, they can probably choose them so that they can have a better energy efficiency. Instead of using heavy transport packaging material, you can use a light packaging material so that you can reduce the transportation costs. Why do I need to switch? So for example, if you have a processing plant here in say Ranchi, if you have to bring an ingredient say from China or from say Europe, there's a lot of transportation is involved in bringing that ingredient. Instead, can that ingredient be procured locally within Odisha or in a neighboring state, so that it cuts short the ingredient cost or transportation cost. You can do energy improvements in the facilities. So for example, most of the facilities now switching to LED lights, and you can also improve the insulation, HVAC, and then you can add solar panels. So, lot of the food processing plants have lot of floor space as well as the roof space. So, you can probably add the solar panels on the top of those plants, so that it can be able to protect or generate electricity that you can use it for running your processing plant. So, you can significantly reduce the operational cost. If you don't have that luxury, at least you can put a what they call reflective coating. So, on the top of your surface you put the reflective coating, so that the light rays are reflected, so that the facility is not overheated. So, a hot summer day like today, you can probably reduce the need for so much refrigeration and things of that nature. So, we already talked about the need for renewable energy. So, you can add solar panels, or if you have a biogas from food waste, let us say like you are processing tomato and then you have lot of pomace left, and maybe you can recover some of the lycopene from the pomace, so that it is a value added process. So, that is part of your valorization, which we will talk later in the class. But then you have some leftover material. That material maybe you can use for making biogas. That can probably provide a source of energy. When possible, you can use wind or hydroelectricity, geothermal. So, geothermal basically it is the energy captured from the earth. So, you can probably do that too. We already talked about some of the novel processing technologies like high pressure, PEF, UV, all those things. They can probably also help, because they rely upon the electricity. So, they simplify the energy use. In addition to that, they have a superior quality product. So, the electrification of food processing probably key emphasis right now. So, for example, Department of Energy in the US identified food processing among the top 5 energy intensive processes. Now, they are kind of encouraging processor to find efficient ways to do that, and in one of the approach being proposed is electrification of various food process operations. So, for example, you can do microwave, ohmic, high pressure, PEF, and then you can also directly convert the electric energy into pasteurization, sterilization applications. One of the benefits of going to food processing, electricity in food processing, is many of the advanced processing, either thermal, non-thermal, they have a very shorter come up time, and they also have a very reduced processing time. So, there is a significant improvement in product quality. You can have instantaneously start up and shut down. When you have a boiler, you have to take time to heat, take time to cool down. So, there is a lot of energy loss. Many of the processes we talked earlier, these are volumetric. So, that means you have less temperature gradient, and you can also, once you use the pumps, electricity, all those things, you can probably do a lot of automation. That means you can control with the computers. So, that means you can have what they call industry 4.0, where you can kind of make a lot of different automations. Once you have those type of things, you can bring in AI and other technologies, so that things can be much more easily integrated. And so, I think there is a lot of potential benefits, but the challenge is when you invest in new process technology is resource intensive, whereas the general process equipment being used, they are used 30, 50 years, many years, and the mindset for the industry is it does not break, do not fix it. So, they just want to keep using it because it's working. So, why do we bother to fix it or change to a new technology? So, the next couple of slides just to show how switching to some of the newer processing methods in different cases probably will help to save energy and save time. So, for example, I can probably pick one here, garlic glove. If you use microwave, it can save about 70% energy. And I can probably look at another one, potato with Womic. There's a 46% time saving, and so on. So again, you have several studies available, and these literatures are available. You can probably take a look at it. Similar way, like you can do these new technologies not only for pasteurization, sterilization, but you can do part of the evaporation, concentration, extraction. So for example, for sugar beet extraction, PF can save about 90% energy. And if you look at pasteurization, high pressure can save about 46% energy in the case of orange juice. And then you can probably do thawing, sterilization, many of these unit operations. So switching to new technology not only improve the product safety, quality and nutrition content, it also help to improve the energy efficiency. Next, we are going to switch to the water use. Food process plants, we use a lot of water, ranging from cleaning, sanitation. You probably use as a part of the ingredient in formulation of products, and you may be using it washing, rinsing product, because like for example, when the fruits and vegetables come, it may have a lot of dirt to it, so you may use water to remove all the dirt. You may use this part of the conveying, heating, cooling, separation process, and then you probably use it for culinary steam generation. And if you look at the big picture in the world, about 98% of water we have is salt water. Only we have about 2.5% is fresh water. So that's the water not only in India but in the entire world. That's the water we have. So most of them are kind of covered in sea, and we probably need to spend a lot of energy to convert that into fresh water. So out of that, probably the groundwater is about 0.7, and then lakes 0.01, and then something frozen about 1.72. So if you look at the big picture, you can see how limited water supply we have. And in that one, how different countries use that water, it's also kind of interesting. Those countries which have a lot of income, so the developed countries, they probably use about 42% for agriculture to produce food, whereas they use 43% for various industrial applications, ranging from petrochemical, cement and all those things. On the other hand, if you look at the developing countries or low income countries, you can see they lay upon a lot in agriculture and food processing. 93% they use there, whereas they probably use almost 2% in industry and other applications. So you can see that the energy use is kind of vary by country to country. It's not just universally every country has the same type of thing. And if you look at the water scarcity, if you look at the graph here in India, it's shown here red. Basically, we are deficit for water because we don't have much water available. Whereas if you look at the United States, they are blue. That means there's no water scarcity. So that means they have plenty of water available through various sources. But you can probably see that there's a red thing creeping in here. So that means like states like California, the west coast of the US now begin to realize water scarcity, or they kind of begin to get that, but it's not as bad as for example India or Middle East and other places. Now you can see there are three different colors shown here, like blue water, gray water and one other water. We will see what those things are. So the blue water basically is the water print associated with the groundwater. So it's coming from freshwater lakes, rivers, aquifer. It's oftentimes used as a drinking water, used by both home and business. and it can be used for irrigation water. And you can probably see in the US, you probably, many parts of the world, you have abundance of um, blue water and then less water scarcity. The green water is the water print associated with rainwater. So whenever, like especially country like India, where there's a like monsoon season, the rain you get is probably the green water. And oftentimes India probably still needs to make a lot of progress, because a lot of times you get a lot of rainwater some days you don't get any rainwater. Then when you get a lot of rainwater, people don't do proper precautions to harvest them. So that means that water run into eventually part of the sea. So you are not capturing that rainwater. So there's more emphasis on rainwater harvesting, so that that water is getting to the groundwater, so that it can probably be useful for a longer time. The gray water is probably the water print associated with the polluted wastewater. So whenever you process it, you may be polluting. When you have household use, you polluting all those things. And so this is kind of the gray water there. So we talked earlier, food processing use a lot of water, and they probably demand for potable water, because they do need to eventually use it for human consumption. And then one of the interesting thing is, most of the time food processors probably not going to purify the wastewater. Oftentimes it's left to the local municipality to treat them and get there. So oftentimes the logic is companies provide taxes, and that way the municipality and they do the services for that. In US, water is cheap, so they can probably willing to spend that much, whereas in India that's not the case. And we have water scarcity in Indian situation, whereas it's beginning to emerge in the US. So there should be a way to reduce water use in food processing, so that you can able to take care of the water scarcity. Other interesting statistics here, if you look at here different food products, how much water, which is green, blue or gray waters shown here. So just to give an idea, if you are making pasta, for producing 1 kilogram of pasta, we need 1849 liters of water. On the other hand, if you are making chicken, for making 1 kilogram of chicken, you need about 4325 liters of water. So this means you are kind of growing the chicken, then processing is the whole thing is included there. Look at here the chocolate. Even though it's favorite for everybody, you can see that it requires about 17,196. So it's from a water use, it's highly water intensive. If you look at beef, 15,415. So again, it's a water intensive process. So the idea here is when water becomes scarcity, which one of the products is easy to make. So maybe you want to ship there and then try to maybe minimize the use of the products which have less water, water intensive use. So maybe this is a question for the group. What can be done to improve water resources in India? How do you, India has water constraint. What can be done? Maybe any thoughts? Just no right answer, bad answer. Yes.
So in many part of India, sir, as we see, people assume that rainwater is replenishing. It will be replaced at the time of monsoon. So the bigger picture would be the foremost thing and basic thing for water resources, to improve water resources, would be rainwater harvesting and educating them. As we know that government at the state level and central level, they are planning in India to dug some kinds of earthen ponds where they can store the rainwater. They are emphasizing on more farm ponds because agriculture took a large extent of water. As a data is can say rice, which take a very much, means 1 kg of rice, it took about thousands of liters of water. So government is planning to harvest the water at the pond level or farm level, so that it can be utilized, and underground water which is a reserve for us should not be disturbed. So sir, my suggestion would be, if the we are taking this to the root level, so we can conserve the water more, and water resources would be beneficial for India.
Right. So the rainwater harvesting, create more ponds, and then conserve water wherever possible. So those are all good suggestions. Other thoughts?
Sir, second one could be the, sir, as we know, from the 70s and 80s time, we were having the participatory watershed management programs are going, where we know that this is the what firstly I have told was the root level, and where the rainwater is we are getting directly. But in the case of hilly areas or river where water flows out, or runoff is such an means problem to collect, so their participatory management can be done with the help of government. And participatory management, because government only can't employ the person to only for the monsoon season, so they can do by creating pond, and the local people with the help of, the name here suggests, the participatory, the participation is must. They can make the check dams there, and so that they can hinder the path of water, and they can brought a channel to take the water to the reservoir.
Right. Yeah, I think again, those are all good points. One other thing I had in mind was, a lot of places you have the water reservoirs evaporate a lot of water with the sun, with the hot suns having in India. So some states I heard now they are putting big solar panel. So it achieved two things. One is it's harvesting solar energy. Second, since the solar panels are kind of placed above the water levels, use the evaporation. Probably one thing. Other thing, with the of lot of cities, the cities what I call uh, jungle. So the floors, everything is there. I think they are encouraging to greeneries along that you can able to harvest water rather than just run off. So if you look at ideal attributes of a sustainable food processing, design a perfect sustainable food processing. I'm going to 100% lay the ingredients made from renewable sources, and it's water neutral. Water, removing any water, when I look at the whole thing, it's neutral. So that means this, I'm not emitting anything after doing my food process operation. Products are completely biodegradable and consumed and biodegradable. So this is very idealistic. It's by nature the food process operations. You are always going to have, you always needs to have more water is needed. You always going to all those things, but the goal is to closer to this idealistic condition. Implementing some of the changes cost, because I think that's a major constraint why they don't want to do it, because of the cost. And then you have some environmental regulations, and there's a need customer demand. Okay, I'm going to buy only a sustainable carbon neutral way, and then they will do that. And then how much those things. So in summary, the biggest consumer of energy, and there's a lot of water is also consumed. Energy costs and reduce the carbon dioxide emissions to improve the energy efficiency. Energy intensive operations with energy efficient, and then energy, some of the conventional new non-thermal technologies, potential opportunities. So with that, additional discussion.